We are going to go over derivatives and we see how to get to simplify them and find the values. So given that y is sec x plus tan x, prove that dy over dx minus tan x is equal to 1. Now, first I'm going to get the y is equal to sec x tan x. Now I want to find the derivative. So dy over dx is going to be equal to, well, what we need to get to realize and know is that whenever we differentiate sec, we are going to get tan x sec x. And whenever we differentiate tan x, we always get sec squared x. So this is what we need to know. And from here, we can now, well, let me just get, how did we get this? And we can use them for the next coming questions. So when you've got y is equal to tan x, tan x is the same as sin x divided by cos x. Now using the quotient rule, dy over dx is going to be v, which is the one which is in the denominator, that is x, and then we differentiate what is on top, the sin x, that will give us cos x, and then minus, we maintain the one which is on top, sin x, we differentiate the one which is down, that will give us negative sin x, and then divided by the square of what is down, x, cos squared x. So that is going to give us cos squared x plus sin squared x, and then divide by cos squared x. Now cos squared x plus sin squared x is a 1, so on top we have got a 1, down we have got cos squared x. So 1 over cos squared x, that is sec squared x. That is why tan, the derivative for tan is always sec squared. What of now the derivative for sec? So the derivative for sec, when you've got y is equal to sec x, sec we know is the reciprocal for cos, so that is 1 over cos x. Same using the quotient rule, we get what is down, cos x, we differentiate what is on top, that will give us a 0, minus, we get what is on top, we differentiate what is down, that is going to give us negative sin x, and divided by cos squared x. So this is a 0, negative 1 times negative sin, that will just be sin x, over what is down here, cos squared x, I can also say cos x, and then also another cos x, like that, because it's cos squared. Sin over cos, that is a tan, and the reciprocal for cos is sec. So this is where this all comes from. Alright, now that we know this, now we want to prove that dy over dx minus y tan x is equal to 1. So I'm going to use this side of the equation to prove, that is the left hand side. So on the left hand side we have dy over dx. Where there is dy over dx, I'm going to substitute tan x sec x, and then plus sec squared x, and then minus, where there is y, I'm going to put, what is our y? Our y is this one. So where there is y, I'm going to put sec x plus tan x, and this is multiplying with tan x. So this is going to give us tan x sec x plus sec squared x, and then we are going to distribute the tan multiplied by sec. That will be, there's also a negative here, we shouldn't forget, that will be negative tan x and then sec x, and then negative, if we multiply this tan with this tan, that will be tan squared. And so this is going to give us, we can see that this is the positive, this is a negative, those are going to cancel out. We've remained with sec squared x, and we know that sec squared is the same as 1 over cos squared x, and then minus, we know that tan squared is the same as sin squared x over cos squared x, and so the denominator is the same, we just get to add what is on top, so that will be 1 minus sin squared x, and then cos squared x, and again we know that 1 minus sin squared is the same as cos squared over cos squared. This is equal to a 1, hence shown. Let's look at question number 2. Find the derivative of y is equal to e to the power 2x natural log of 2x minus 1. Now here we've got a product of two functions. We've got this function and then we've got this function which are multiplying. And we know that when we want to find the derivative for a product, we first get one, we differentiate the other, and then plus we get the other, we differentiate the one. And so v here, we're going to say, we can name any. Let's say u is the first one and v is the second one. So I'm going to maintain the second one, that is natural log of 2x squared minus 1, and then differentiate the first. Now when you are differentiating e to the power 2x, this, you just differentiate what is on top and then you multiply with the function which you have. So if we differentiate 2x, that will be a what? That will just be a 2, and then we multiply with the function itself, e to the power 2x. So that is the derivative, and then plus. Now for the second one, I'm going to maintain u, so that will be just e to the power 2x, and then now I'm going to differentiate v. So whenever you're differentiating a natural log, just differentiate what is inside here, 2x squared minus 1, that is going to give us 4x, and then divide by the same thing that we differentiated, that is the 2x squared minus 1. And I can just simplify this. This will be 2e to the power 2x natural log of 2x squared minus 1, and then we have got plus, this can also be written as e to the power 2x and then 4x divided by 2x minus 2x squared minus 1. So that is going to be it for this one. Now given that y is equal to e to the power x plus x squared, prove that d2y over dx2 is equal to y plus 2 minus x squared. Well, the first thing is, let's find dy over dx for this one, and then find d2y over dx2. So dy over dx is going to be equal to, when we differentiate e to the power x, simply differentiate x and then multiply what you find with this same term. So the derivative of x is a 1, and then 1 times e to the power x will simply be e to the power x. So the derivative of e to the power x is itself, and then we differentiate 2x squared, that is going to give us 2x. Now d2y is differentiating this for a second term, so that would be d2y over dx2. Now this is going to give us, again, differentiate e to the power x, it will just give you e to the power x. Differentiate 2x to just give a 2. Now we'll come on this one. We want to show that d2y over dx2 is y plus 2 minus x squared. And how are we able to show that? Well, d2y over dx2 is equal to y plus 2 minus x squared. I'm going to use the right hand side of this identity. So right hand side is equal to, where there is y, I'm going to put my function. Our y is this one. So that is e to the power x plus x to the power 2, and then plus, we'll write 2 minus x squared, like that. Okay, from here we can see that this one cancels with this one. So this is giving us e to the power x plus 2, which we can see is the same d2y over dx2 which we found, hence shown. Let's consider this one. Find dy over dx of x. So we have got y is equal to x cos 3x squared plus a 1. How do we get about it? Well, we can see this is a product. We have got x multiplying with this. So whenever it's a product, dy over dx is going to be equal to v du over dx plus u dv over dx. So v, I can get anything as v and anything as u, but mostly you get the first as u following the alphabet and the second as v. So I'm going to maintain the second, that to be cos 3x squared plus 1, and then differentiate the first. Now if I differentiate x, I'll just get a 1, and then plus maintain x. Now differentiate the second one. Well, the first thing that we do when we're differentiating a cosine is first differentiate cos, and we get it from here. We have got cos x here, we've got negative cos x. We have got sin x here, we have got negative sin x. So when you are going in this direction, that is giving you the derivative of each term. So here we've got cos x. When we differentiate cos x, it gives us negative sin. and so we are going to put negative sin, but the angle will just maintain it the way it is, that is 3x squared plus 1. After we do that, now we go and differentiate the angle. 3x squared plus 1, differentiating that, that will just give us a what? A 6x. And so this is going to be equal to, we have got cos 3x squared plus 1, and here we've got 6x, which we can multiply with negative and which we can multiply with this x here. So that will give us negative 6x squared, and then we have got sin 3x squared plus a 1. So that is going to be it for this one. Now we have also this one. Find dy over dx given that y is equal to the square root of x squared minus 1 sec x. How do you get to find the derivative for this one? Well, dy over dx, we've got a product here, and this product we can also write it as x squared minus 1 to the power 1 over 2 and then sec x. So this is going to be v du over dx and then plus u dv over dx. Now let's call this as u, this as v. So we'll first get v the way it is, that is the sec x, and then differentiate the u. Now here we'll first multiply the half with the function itself, that will be 1 over 2 and then x squared minus 1, and then subtract a 1 from there, that will give us negative 1 over 2. After we are done with that, now differentiate what is inside, that will just be a 2x. Okay, if we do that, then plus, we go on and maintain the first one. The first one is x squared minus 1 to the power 1 over 2. Now differentiate the sec x, and we saw that when we differentiate sec x, what we get is tan x sec x. And so this is going to give us, these 2 can cancel out with these 2, and we will just remain with an x. This x I can multiply with the sec x, which is outside here. So that is going to be x sec x. We shouldn't multiply this x with this one because that's an angle. Now this one has a negative power, so we can take it down. So over x squared minus 1 to the power 1 over 2, and then plus, I can also write here now, that is x squared minus 1 to the power 1 over 2 and then tan x sec x. So what are we getting here? We can make this as a single fraction. So this is over 1. I'll multiply this with what is down here. That is going to give us x sec x, and then multiply this with this one. Now we can see that this term and this term, they've got the same power. So numbers of bases which are the same, multiplying, we simply add the powers. So this will be equal to x to the power a plus b. So we know half plus half, that will just be a 1. Therefore this will just be x squared minus 1, and then we have got tan x sec x. And then in the denominator we're going to multiply this one and this one, and that will give us, of course this can also be written as the root of x squared minus 1. We can as well simplify from this point by factorizing out a sec. So we can also write this as sec x, then what is going to remain is x, and then on the other one what is going to remain is a tan x, and then we have x squared minus 1 inside, and then in the denominator we have got the square root of x squared minus 1. So that is going to be it for this video. Thank you so much for having been present. Please be sure to subscribe and be able to follow other videos, and also share the link to help us know how we are moving. Thank you so much for watching. Enjoy your day.